Hello everyone. So my name is Ganesh and today I wanted to talk about Github Actions and show you how or why you can use them and what all things you can do with it. So if you don't know, stick around, you might find out. So starting up with what is Github Actions? So I would describe Github Actions as something like an automation. So it is some sort of an automation that you write as a code inside of your repository that is hosted on GitHub. And this automation can do a lot of things. Okay, so uh, let's say you just want to say hi, so you can print hi. Let's say you wanted to send an SMS message, you can send an SMS message. Let's say you wanted to raise some alert, you can do that. Let's say you have an application and you want, and this application is cross platform, so it runs on Windows, Linux, Mac, and God knows what platform. With GitHub Actions you can build it for all the different platforms. Let's say you have a very complicated library which does a lot of complicated things. You can write tests and run those tests on GitHub Actions and make it automated so you don't have to run it yourself, and make it show the results on your repository page itself. So a red cross would mean your tests have failed, and a green tick would mean that your tests have passed. So this is just an example of things that you can do, but yes, these are the sort of things you can do with it. Now let's look at one of the files with which, or sorry, let's look at the format in which you can write a GitHub action and make it do things. So here if you see on the screen, I have an action which is defined very simply. And to make it short, every action file is divided into three major parts. First is the metadata part, where you actually store information about the action itself. So basically its name, description, everything. And that is, defined at the very top. And the second part is the trigger. So as I said, this is an automation. So it basically automates certain thing. And all of the automations normally happen after you do something. So you need to define like when you need this action to run. So there is this trigger part, and the third part is what do you want this action to do. So this goes inside the jobs part, and inside jobs you can see I have one job defined, which is a demo job, and this runs on Ubuntu, and it has a bunch of steps that it does. Gets the repository code itself, runs in hello world, and runs another hello world, but this time it's a multi-line print statement. Let's look at how you can run this. So if you see the trigger part, I have two main different types of triggers defined. First is workflow dispatch. So this means nothing but I can go to the actions tab, search on this action particular, and then dispatch it myself. So basically manual dispatch, workflow dispatch. And the second is whenever a push action happens. So a push action is whenever you do git push, right? That is what this is. So whenever you have pushed something on the main branch, get it? That's it. Now let's try dispatching it. If I go to the actions branch, and here I see there is a demo action already defined, I can click on run workflow and dispatch it myself. You can see that I got a message that workflow run was requested. It started running. uh, it is a bright yellow at this point, and if I click at this, it has already completed execution. So in the world, yeah, see, same thing. Yeah, so in the earlier example, we saw how you can do basic scripting inside of your GitHub Actions. Now, what I will show you is how you can interact with the code that you have in your repository. So let's say if you have a Python application, how do you run it? How do you build it? How do you set it up using GitHub Action? So let's look into that quickly. So yeah, before we start doing any of the code related things, changes in our GitHub Actions, I want to actually showcase you um, what our code base looks like and what it does. And I'm sorry if you hear a baby cry. There's a baby right next to my house, and he's crying out very loud right now. But let's see our code. So right now in our repository, we have two files. One is main.py, which is basically uh, the entry file. So if we run this, this is our entire application. And if you look at the code, I just have a main function in which I print a statement, then I do addition, then I do subtraction, then I do multiplication, and then I do divide. I'm a bit of a maths guy, if you know. And and these are the four files that I have. Sorry, these are the four functions that I have defined. And when we run our src.main.py, this basically gets executed and it calls the main function. And inside the main, all of the other gets executed, right? And if you look at the test.py, it is nothing but basically testing all the functions. So if you call the addition function and you pass these two things, this should be the result. If this is not, then the code has some bug in it. So that is what all of these functions do. And yeah, when we actually run those functions on GitHub Actions, this sort of an output you should see there. What you can do is inside of this workflows directory that we already have, and yes, maybe I have forgotten this telling you this before, but all of the actions that you define, they go in a very special directory inside of your repositories. It's not like you can just define a file and anywhere in the repository. It's not that. It should be inside .github/workflows. So let's create another one here, and let's name this application.yaml. And yeah, again, remember the three parts. First, the metadata. Second, on trigger. And the third part, that is the actual jobs. Okay, so I mean, this is already giving me some suggestions, but I do not want that. Yeah, so let's look at things. um so here, in the action that we have set up, you can see that I have defined very basic steps in which first, as we did in our previous action, we did check out the repository. We are checking out the repository, and once you check out a repository, it is basically checked out at the very root level of your action. So let's say if you are running an action and you checked out a repository, all the contents which were there in the repository will be accessible to you just like it is available here. So if I do ls, you can see that I have the src directory here. um, I should do lsal so that yeah, so the directory structure will look something like this, like in the in the actions server where this will run. If you have checked it out, it will have things like this, if it makes sense. Okay, and then since you already have the repository checked out, you can just, uh, as you know, we have this vn folder in gitignore, so it will not get pushed to github. So we basically need to create another virtual environment up over there. Once we have that created, we can activate that virtual environment, and at the very end we can basically install all the requirements we want. um, for this we don't have any requirements as of yet, so we just gonna have an empty requirements.txt file, and at the very end you can just run this. So this has given me a wrong suggestion. What I will do is python src main.py. So this should ideally work. Let's see. Hmm, actions, play with action, run, and hopefully it runs successfully. We click on it, build, and yeah. So see, it did actually as we wanted it to do. So just that. So if you check the build logs, or sorry, the action logs of this, you will see that it does basically a bunch of other steps as well, before doing the steps that we have defined. And that is because the agent which runs this job um, does not know anything about our project, right? So it basically need to have some context regarding our project. And second, like, so that is why it runs some jobs before the things that we have defined, and it does also run some jobs after we have completed our execution. That is to clean up all the things that we have defined in our action. So let's say if we were logging into some website in our actions, as soon as the job was completed, you don't want your credentials to be stored on the server, right? So that is why post cleanup things happen. Right now here we are not doing anything, so you're not seeing anything. But if you were supposed to do something like that, the the steps which run after your description do basically clean all those things up. Now I want to always also show you this. So basically what I want to show you is how you can build your application. So right now what I mean by building is like creating a binary file. So most of the time when you are using a machine, let's say Windows or Linux, you have an exe file that you run. And when you're writing some code, you don't write code in exe format. You write in the language specific files. For Python, it will be .py. For Java, it will be .java. For Golang, it will be .go. But those, you don't run those files when you use the applications. You run platform specific files. For Windows it is .exe. For Linux it's just basically binary files. Same with Mac OS. So it's not that there is some different language for that. It's the same programming language that you use, but it is packaged in a way that, the operating system understands it. So that process is called building. And right now our project is not building anything, so you basically cannot run it anywhere. So let's, you know have an action where we build it for different operating systems. Let's try that. So I'm gonna again create another file, or let's just copy the same file. So inside of our GitHub directory, inside the workflows, there is an application file. We want it to be copied to GitHub workflows, build.yaml. Okay, so it's basically the same file. And also let's change the branch name to main so that it automatically triggers. Yeah, so in that situation, yeah, let's just see how you do that before actually writing an action for it. So in Python, there is a tool called PyInstaller, and there are different tools for every language that you write code in. So for Python, there is PyInstaller. For different language, there will be different tools. So what PyInstaller can do is, if you provide the binaries name to it, it will bundle the application and create an exe, or basically an executable, and make it available for you. So let's do that. So first let's install PyInstaller on our project. I already have it installed because I was playing with it, but once you have it installed, you can just do this, and it does a bunch of process. And although it says exe, whichever platform you are running it on, it will create package for that platform. I'm not sure if it has options to create for other as well. Yeah, let's not get confused over it. But this is basically the process. So you basically provide PyInstaller and the binaries name, and you can see that it created a bunch of files. Now we don't want all of those to be present in our um, repository, so I will add them to git ignore so that git ignores them. And yeah, so now since we have those in ignore, let's see the output of that command that we ran earlier. So it built an exe, and it is present inside the dist folder. Not sure where it writes that. It should be somewhere in the logs. But yeah, whenever you do PyInstaller, it basically creates a executable and puts it inside the dist folder. So right now inside the dist, if you see dist, you will find another folder that is main, and inside that you will find an executable that is main. So let's just convert this file into something that can be executed. Dist slash main, and now let's try to execute this. And lo and behold, you see that it actually did run our executable, and we did not need to call Python and then pass in our file or anything. Yep, so it makes sense. So let's say we do that in our build.file. So again, so uh, to build this executable, you understand that I had to do basically do PyInstaller install, and then I basically, you know, pasted the file's name. So so in our GitHub Actions, when we do that, that will not have PyInstaller uh, on that agent present. So we need to make sure that agent also has PyInstaller. How can we do that? In the previous section, we created this requirements.txt file, but it did not have anything. Let's add our things there. So if we basically freeze the requirements of our current local and put it inside txt. So let's first see what that pip freeze do. Pip freeze will do nothing but basically list all of the packages that we have locally. So if we do inside of our requirements.txt, it will add all of the files. So here it has PyInstaller and all of the other dependencies in it. So now since we have this in our requirements.txt, and inside our before committing, actually, let's change this, and then we just do and then pass in our binaries name. Okay. um, yeah, there is also this parameter. Let's try that. And now if we run this, yeah, so now, mm, so this basically did was, earlier if you saw inside dist, there was another folder in which there were another files, but after passing this dash dash one file, what it did was basically create just one single executable and no other dependencies. So I think that's a better way to do things. And yeah, so we will try doing that on GitHub Actions now. So let's add this. So basically, let's try fixing that. Yeah, so now it actually did find it somehow. Okay. So yeah, now we did build the binary. Let's try to get this. Yeah, now we did build the binary, but we don't know whether this binary is good or not. And also, since this job was running just on Ubuntu, it will only create a binary for Ubuntu. We don't want that. We want to create binaries for every different operating system that there is. So let's try to modify our action so that we can do that. So inside of our uh, this thing build, we can do matrix and then oh sorry uh, strategy, and inside that matrix, and inside that have other operating system, and then inside this matrix.os, and then let's try that. So and also we want to be able to have it pushed somewhere, right? So let's look at some. Yeah, we want to basically have this executable files so available to us so that we can test it. And the way we can do that is basically uploading them as an artifact. Now, what an artifact is nothing but just another file, but it is stored as an output of your action. So right now, since we are building these binary files, and you already saw that, you know, and you already saw that we are building it for different. So here, since you see that we had a matrix, now this action is running on 3 different machines at the same time. And I mean, we will see the output of all of those in quite some times. But what happens is, let's say if you have, yeah, one job has already completed. So let's say if you have some thing that you want to run on different machines, you can do it using matrices. And one thing failed and one thing got cancelled. Okay, so I was facing issues with Windows build, so we're just gonna skip that for now. And we're gonna build the application for Linux as well as Mac OS. So let's do that because they both are very similar in terms of how they build things. If I ever find time again, I will do it for Windows as well. And yeah, let's do that. Windows just is confusing to work with. Sorry. I mean, I would not say it is bad. I would just say that I don't know for what reasons they have chosen to go a different route, and it hurts me to work with that. Yeah. I don't know why. So yeah, let's see that. It is like the Ubuntu latest one has already completed. We are waiting for the macOS one to build. Okay, I think the macOS one started a bit late. Like setting up job took a long time. But after that, it has been fast. And yeah, I think it should be fast. And yeah, if you see the actions and inside our action, here where this is running, you can see that two files are already present. I can basically download one of those and maybe see how it is. Yeah, like if I go here and open up my file and execute, yeah, you can see that one file is already here. If I go to my terminal, site downloads, and just do chmod plus execute main, and I just run this now. It should run successfully. Oh, come on. For some reasons, macOS kills it. Yeah. What? Okay, so now it should work. So what happens is in macOS, there is a long story short. Yeah. So what happens is macOS is the by normal means they block all those things, but if you click on like right click on it and open with this, it basically asks for your permission, and if you allow it, you can run it basically. So now you can see that we got this file from GitHub which was already built and we ran it. The same can be done with the Ubuntu build, and if Windows decided to work, that would have worked as well. But apart from that, yeah, that is how basically you do it. So that was enough for today's session. Maybe I'll make another video sometime later where I show something else, but that was it for now.